on this computer. Okay, now. So for the very first one, compute each of the following integrals. So we got three terms here. Okay, and root x is same as x raised to 1/2. And we know that when we have x raised to some power n, when n is not -1, and when we integrate, that is x raised to n plus 1 divided by same thing. And it should not be a 0. When n is -1, then this becomes 0. So we got three terms, and we're going to use this power rule over and over. And for the numbers, we can simply pull out. So for this question now, then it's going to be, let me write one extra step. So I'm going to write antiderivative of 3x squared in this way. 3x squared minus 2x cubed. And this step is optional. You don't have to show this step. Plus antiderivative of root x is x raised to 1/2. Now I'm going to apply this power rule for each of these three terms. Then this is 3. X squared means x 2 plus 1, 3 over 3. 2 times x 4 over 4. And here x 1/2 plus 1, which is 3/2. So x raised to 3/2 divided by same thing. We get constant from each term, but there are three, and we collect them as plus c. You can leave here, but it's always good to simplify. As you can see here, 3 cancel, 2 goes 2 times, and this 3/2 bring to the front. That makes x cubed here minus x 4th over 2, which is same as 1/2 x to the 4th, and plus here is 3/2. You can pull to the front. That means it flips. 3/2 becomes 2/3. X raised to 3/2 plus c. Okay, so that's the first part. Questions? Should be straightforward, right, by now. Now the second is the same thing. We got 1, 2, 3 terms. We got negative exponents, but we can use the same power rule. Let me simplify here. 2x squared cubed. We cannot apply power rule yet because this is 2 cubes and x squared cubed. This, when we simplify, 2 cubed, which is 8, x raised to 2 times 3 is 6. So if I simplify this, this is 2, 8, x 6, oh, x to the -1, that's just like xn, plus 4, x to the -2. And by the way, this power rule, this does not apply when n is -1, because n equals -1 makes the bottom 0, and something divided by 0 is undefined. But here is x to the -1, so it's better to write negative exponent as 1 over x, because x raised to -1 is 1 over x, and when we integrate, antiderivative of 1 over x is just natural log of x. So then this one we can do 3 terms. So 8 x 6 plus 1, 7 over 7. Antiderivative of 1 over x is natural log of absolute x, plus 4 x times x raised to, so -2 plus 1, that's -1. So you have to be careful. This -2 plus 1, -1 divided by -1. That's it, plus c. You may leave here, or you can simplify. So this is, if you want to simplify, it's 8/7 x 7 plus natural log of x. Here is 4 over -1. That's -4 in the front. And x raised to -1, you may leave there, or that's 1 over x plus c. Okay. Now the next is it's the same thing. I'm in the third problem now, and there is a recording. You need to watch previous. If you missed, Nina, you need to watch the previous. In part C, we got 2 over x plus 8 over x cubed, two terms, pretty simple. And we just saw when we have 1 over x, this is just ln of x. And if we have a number on the top, we can simply pull outside. So in this case, you can separate into two fractions. This is pretty much 2 over x and 8 over x cubed. These are two parts. You don't have to separate, but if you separate, then you can see, oh, we have combined two fractions. And now antiderivative of 2 over x is pretty much 2, pull outside 2, is 1 over x. And here we can do the same, pull 8 out, 1 over x cubed. I'm going to move up x cubed so that I can use the power rule, x to the negative 1. For 1 over x, I do not move up, because 1 over x is x raised to negative 1. And if you look at this power rule, this does not apply when n equals negative 1, because we will be in trouble. We are getting 0 on the bottom. So then we can finish everything in the next line. This is now 2. Antiderivative of 1 over x is natural log of absolute x plus 8 x to the negative 3 plus 1. Okay, you need to be careful. Negative 3 plus 1. That's negative 2 over negative 2 plus c. This could be the final answer, or if you simplify, 2 natural log of x. Here is 8, negative 2 on the bottom. 2 goes 8 4 times, and negative, that's negative 4 x to the negative 2 plus c. X to the negative 2 you can pull on the bottom, but this is good enough. The best you can do here is negative 4 over x squared plus c. Now in part D, we got a fraction. This is not new. Any idea? What are you going to do? There's a fraction, so.
Break it apart.
Yeah, break it apart. All the time, whenever you see a fraction, and if it is possible, that's the case. So we can do 1 over x cubed, x over x cubed, x squared over x cubed. Okay, so we are in part D, Michael. So whatever missed, you can recover that on video later. I'm going to post that. So when we have a fraction, we try to break it apart if possible. It is possible here, but in some cases it's not. Then we'll look for more advanced methods like U-sub, then trig sub. That's what we are doing. But here it's so simple. We can separate into three fractions. Let me simplify. 1 over x cubed is same as x raised to negative 3. I'm writing in this way so that I can apply the power rule. And x over x cubed, okay, when you simplify, x 1 copy on the top and 3 copies, you cancel 1 copy from top and bottom, 2 copies left on the bottom, and move up, that's x to the negative 2. Okay, x to the 1, x to the 3. You are canceling 1 copy from top and bottom and move 2 up. In the same way here, cancel 2 copies from top and bottom, and that is move up x raised to negative 1. But don't write x raised to negative 1, because we cannot apply power rules. So here I would write 1 over x, because I know antiderivative of 1 over x is natural log of x. So you want to simplify in this way and finish the problem in next line now. Power rule over and over. X n plus 1, same thing on the bottom. N plus 1, same thing on the bottom. And antiderivative of 1 over x is just natural log of x plus c. You may leave here, or the best you can do is this negative on the bottom 1 over 2. So negative 1 half, and x to the negative 2 you can bring to the bottom so that negative exponent gone. Plus this negative 1 on the bottom, so that negative you can pull to the front, And then 1, no need to write. And x raised to negative 1 is 1 over x plus natural log of x plus c. Maybe you don't have to copy this because I'll have PDF copy available and video also available. So if you watch me, then I can move. I mean, we can go fast like what I'm doing. I do not copy yet. I'll have the PDF file available as well as the video available. So if you watch me work out, then that might help better. Okay, part E, again like part D, because we have a fraction and we might be able to break it apart, and that's the case. So cube root of x on the bottom, as we know, cube root of x is x raised to 1/3. So this is x raised to 1/3. So we can break this apart as follows. 1 over x raised to 1/3 plus 2x over x raised to 1/3 plus x cubed over x raised to 1/3. Okay, now we need to simplify. Okay, this video will be available as well as PDF file is available. So those who joined late, you can just watch me work here and please ask question in the middle. Okay, I want your question in the middle, and that might help other people as well. So cube root of x is, you can just watch and you can copy this later. Then now we need to simplify. So 1 over this in fraction, just move x on the top. So that's negative 1/3. Here plus 2, how about x and x raised to 1/3? So x over x raised to 1/3. X means x raised to 1. When we have the same base, we write the same and move 1 3 up. So 1 minus 1 3. This is how we combine two fractions. And that is x raised to 1 minus 1/3 is 2/3. So this is pretty much 2x raised to negative 2/3. No, positive 2/3. Here, so same thing, x cube over x raised to 1/3, similar to this. So x raised to 3 minus 1/3. And what is 3 minus 1/3? 3 means 9/3. Okay, 3 is 9/3 minus 1/3, 8/3. So you can just make common denominator. 3 means multiply 3 over 3. So 3 is 9/3 minus 1/3, so 8/3. So this is plus x raised to 8/3. And now once you do this algebra, then next step is all power rule in each term. All you have to do is power rule of integration. So this is xn. So xn plus 1, negative 1/3 plus 1, negative 1/3 plus 1. That's positive 2/3 divided by same thing plus 2 times x raised to 2/3 plus 1, 5/3 divided by 5/3 plus x raised to 8/3 plus 1. So 8/3 plus 1, 1 is always 3/3. So 8/3 plus 3/3, 11/3. So this is how I'm working out in this. Plus c. You may leave here. Okay. The best you can do is just write down this 2/3 as a 3/2 here when you bring to the front. So 2/3, it flips 3/2, x 2/3. This is 2 times 3/5. Now 5/3 becomes 3/5. So this one is 2 times 3/5. When you multiply the tops. This 6 over 5. So this is 6 over 5, x raised to 5/3. And 11/3 means 3 over 11. X raised to 11 over 3 plus c. Okay, and you may leave here as well. part F. So we got a fraction, but the top is not nice. Unlike part D and E, the top of the F is not good. So we need to simplify the top first. So we got 5 times 2x plus 3 squared. Unfortunately, you cannot multiply inside. No, do not multiply inside yet. It's not allowed. So square means you need to square first, then multiply by 5. 5, 2x plus 3 square means 2x plus 3 times 2x plus 3. And you're going to FOIL just first, outer, inner, last, FOIL, FOIL. Then when you multiply, this is 5, 4x squared, 6x, 6x, 9. 6x plus 6x, they are like terms. You can combine these two. But 4x squared is not. You cannot combine with other terms, okay? When you combine variables, you need to add only like terms. So this is 12x, this is 5, 4x squared plus 12x plus 9. Then distribute 5. Okay, so that I'm going to write over here. So that goes on the top. So this one is 5 times 4, 20x squared plus 5 times 12, 60x plus 5 times 9, 45. So that's on the top, and we got ax cubed. Now we can separate into 3 fractions like previous questions. So I'm going to do that quickly because we've done twice before. So 20x squared over x cubed. That's 20. We can cancel 2 copies and gonna write 1 on the bottom, 20 over x. And let me write this 20 as 20 times 1 over x. Same thing. That way, when I integrate, antiderivative of 1 over x is natural log of x. So 20x squared over x cubed, I'm going to write 20 times 1 over x. Plus, here 60 times x over x cubed. So x over x cubed is, by the way, cancel 1 from top and bottom, 1 over x squared, and move up x to the negative 2. Plus 45 over x cubed, that's the 45 over x cubed means move up negative x cube on the top. So this is how you simplify. The good news, you can try on your own, and later if you review the video, you will see all the details. Then you can challenge yourself whether you got correct or not. If you just copy, then everything feels good a lot of times, and when you try, you might make a mistake. So, but the video is here for this. Now we are ready to integrate. So this is 20 antiderivative of 1 over x, just natural log of x, plus 60 times x, negative 2 plus 1, negative 1 divided by negative 1, plus 45, okay, 45 x to the negative 3 plus 1, negative 2 over negative 2 plus c. Now, you may leave here. The best you can do is 20 ln x. Get rid of negative exponent. So this is negative on the bottom, 60 over negative 1. That's pretty much negative 60. And x raised to negative 1, put on the bottom. Here, 45 over negative 2, so negative 45 halves. X to the negative 2 on the bottom, move downwards, plus c. But if you leave here, that works for the exam, okay? I would not waste time writing the very last step, unless you have to do further calculations. In part G here, we got t times t square minus 1 squared. Same thing like the top of previous question. We need to simplify, and we cannot multiply inside yet. So this is t times, we want to multiply t square minus 1 square means t square minus 1, t square minus 1. And this problem can be solved using u sub as well, because derivative of inside function is 2t and we have t here. But for now, just square, we can just multiply, simply multiply. That is t4 minus t squared minus t squared plus 1. That is t fourth minus 2t squared plus 1. Okay, then t times, if I square it, then this is t fourth minus 2t squared plus 1 dt. Okay, we cannot integrate yet because we have still a product. If we had a number, we could have taken outside. But here, t, distribute t to the 5 minus 2t cube, multiply means add the exponents, 1 copy, t squared 3 copies, plus t times 1, just t. Now we can finish in the next line, use power rule in each of these 3 terms. Okay, and I'm going to do this by u sub as well, because we are lucky it's square. It could have pip power. Yeah, something's calling. Now let's integrate here. So t to the 5, that is now, it's like xn, t to the 6 over 6 minus 2 times t cube means t 4 over 4 plus t means t raised to 1, by the way, that is t 1 plus 1, 2 over 2, t square over 2, and we write plus c. But this question, alternatively, okay, we are lucky because it's square. So let me do over here, since we know advanced methods. I meant to use different color. Okay. It's the t times t square minus 1 quantity square dt. Here's a product. There is no product rule. The good news, if we assume the inside is u, okay, what is derivative of t square minus 1? Just 2t, right? 2t. And 2t means we have t, and we can always manage the number. We can just divide, multiply. We cannot manage the variable, but that's not the point. That's not the case here. So we can manage the number. So let's do it. U sub. So let u be t square minus 1. Then du over dt is 2t. I'm going to write dt on the other side. That gives dt equals du over 2t equals dt. Now this integral is then t is just t times t square minus 1 is u is square. And dt is found to be du over 2t. Then this t and t cancel. Always the original variable should be gone when we make u substitution. And there is a 2, that's on the bottom. So this is 1/2 when we pull all the way outside. 1/2, that leaves u squared du. And 1/2, antiderivative of u squared is u3 over 3 plus c. And that is 1/2, 2 times 3, 6 on the bottom, 1/6 u cube. And u is t squared minus 1 cube. T squared minus 1 cube. and plus c. Okay, these are equivalent answers. Might not be the exact, but they are equivalent. Okay. Let's look at number 2, part A. Okay, we got definite integral 0 through pi over 2, 1 minus sine square over cosine d theta. So we got a fraction. Any idea?
Isn't 1 minus sine squared just cosine squared?
Yep. And then, yes, but the thing is, how does that help? If we write cosine square theta on the top.
Couldn't you cancel it out similar?
Yeah, perfect. That's what you need to do. Sometimes you have a formula available, but that might not help, right? So in this case, it helps because 0 through pi over 2, 1 minus sine square is cosine square. Now you can cancel one copy of cosine from top and bottom. So one copy cancel, just cosine theta left. Now we can find the antiderivative of cosine, which is what? Do not get confused. It's not negative sign. A lot of times, yeah, it's sine. I would always say doing derivative. A derivative of sine is cosine. Okay, and now no plus c required because we need to evaluate from 0 through pi over 2. Now this variable theta is replaced by pi over 2. So sine pi over 2 minus lower limit 0 sine 0. Now you can check in your calculator. This pi over 2 is a good angle. So sine pi over 2 is 1. You can check in your calculator. Sine 0 is 0. So the final answer is 1. Okay. So the whole idea here, as soon as you realized 1 minus sine squared is cosine squared, then the rest is pretty simple. How about here, part B? Secant square minus tangent square. Similar to part A, do we have any formula?
It's equal to 1.
Yeah, it's 1. That's another identity, like sine square plus cosine square is 1, and secant square minus tangent square is also 1. You might have seen this. 1 plus tangent square is secant square. And if we modify this, if we subtract tangent square from both sides, yep. So this one is 1 over cosine square theta. Oh, we still have a fraction. It's a cosine square, but pretty much reciprocal of cosine. So what is 1 over cosine?
Isn't that just secant squared?
Yep. 1 over cosine. Yeah, reciprocal of cosine is secant and square is there. Secant square. So this is, I don't know. Okay, it's somehow, at least we got rid of the fraction. Okay, it's much better because we don't have formula for fraction. Secant square. Now you should remember secant square is derivative of tangent. That means antiderivative of secant square is just tangent. And plus c is always there. So whole thing here is secant square minus tangent square is 1. Now part C, okay, we got a product on the top, product on the bottom. So it's the secant cube means secant theta, secant theta, secant theta, 3 copies, tangent 4 copies, tangent cube 3 copies on the bottom, secant square. We can cancel. Look, secant square 2 copies, we got 3 copies on the top, just 1 copy left. Same thing for tangent. 3 copies cancel. For tangent, 4 copies, 1 copy left. So we got secant theta times 1 copy of tangent theta. Oh, then you need to know this one. Secant theta, tangent theta is the derivative of secant theta. That means antiderivative of secant tangent is secant. Okay, this is just the formula. Okay. Part D, 1 plus sine square theta over sine square theta. Again, fraction, similar to previous. Do we have a formula for 1 plus sine square theta? We do have sine square plus cosine square 1. We can subtract sine square from both sides. Nope. Okay. We do have for 1 minus sine square, but not for 1 plus sine square. Okay. Do not blindly write cosine square. Oh, this Zoom is now lagging. So as soon as I finish second page, I'm going to stop and make two-part videos because it's lagging. So there is no formula for 1 plus sine square theta. Then I'm not going to write this anymore. Any idea? What did we do earlier when we had a fraction? We split into two, right? Break it apart. I mean, that's another hope. I don't know whether that works, but we'll try. So that's 1 over sine square plus sine square over sine square. Oh, that's 1. I didn't have to write this step. It's lagging. Any idea what 1 over sine square is? It's a reciprocal of sine.
Cosecant?
Isn't
Yeah, cosecant. Cosecant is squared there, right? Plus sine square is just 1. Now you need to know the basic trig integrals. Cosecant square theta. Cosecant square, derivative of cotangent is negative cosecant square. That means antiderivative of cosecant square is, what do you think? Oh, that is negative cotangent. Okay, pretty much formula. It's just a simple formula. Okay, it's lagging. Okay, it's just coming now. Negative cotangent theta plus antiderivative of 1. We would say x, but our variable is theta, so plus theta. See. So this is simply a formula. Antiderivative of cosecant square is negative cotangent. Part E, 1 plus y square all over 1 plus y square quantity square. Okay, same thing, and 0 to 1. Okay, looking at this fraction, for me, it looks like one term and square on the bottom. So what is x over x squared? Can we simplify this?
Yes. You can cross out.
One copy and just 1 over x, right? Yeah, same thing here. 1 plus y square, we can just make a block. It's not coming there yet. Okay, 1 plus y square. Now I can cancel one copy from top and bottom. That leaves 1 over 1 plus y square, one copy on the bottom, dy. Just 1 plus y square, one copy left. Now, by this time, you should memorize, okay? This is a fraction when you have 1 over 1 plus x squared. That's the arctangent. Okay, it comes a lot of times. In next week, starting tomorrow, you will see again and over. So 1 over 1 plus y square is just tangent inverse y, arctangent, and we got from 0 to 1. Now we replace upper limit tangent inverse 1 minus tangent inverse lower limit 0. And we know that tangent of 45 degrees is, or tangent of pi over 4, because calculus does not work on degrees. Okay, you can never write degrees, only radians. Tangent pi over 4 is 1. That means tangent inverse, arctangent of 1 is pi over 4. And tangent 0 is 0. That means tangent inverse 0 is also 0. So the final answer is pi over 4.
Dr. DeHall,
Hmm?
how did you solve for tan inverse there?
Okay, this so tangent of pi over 4 is 1. You know, tangent 45 degrees is 1.
Okay, okay, you did it
That
backwards.
means, yeah, other way around. We had one question in test 1. So that is now tangent inverse of 1 is pi over 4. Okay, same thing. There's one more. Cosine 0 is 1. I mean, this one shows up a lot of times. That means our cosine of 1 is 0. Tangent 0 is 0. Sine 0 is also 0. But cosine 0 is 1. Okay, that's the other way around. So tangent inverse of 0 is 0. Sine inverse of 0 is 0 as well. Oh, it's coming so late. Yeah. Okay. So part F is the fraction of second ex cube over e2x. So we can simplify the second. Ex cube is in fact okay. It has not shown up there. What is this? What do you think? E raised to
3 times x?
Yeah, it's not x cube. Yeah, you got it. Perfect. 3x. Inside exponent, outside exponent, you multiply. It's 3x. And on the bottom, we got e to the 2x. Now we got the same base e. Okay. And 3x, this 2x move up minus 2x. And just e to the x. So this fraction is in fact 1 through ln of 5, 1 minus, if you simplify this, it comes out to be e raised to x. Okay, now it should be pretty simple now. Now we integrate and apply the limits. So antiderivative of 1 is x minus antiderivative of ex is just ex. Plus is not needed. Now we go from 1 through ln 5. Now we replace the variable x by ln 5 first, then later by 1. Oh, in two places. So two terms means put parentheses around. X is ln 5 minus e raised to ln 5. Okay, it's lagging a lot. That's the upper limit, replacing x by ln 5, minus lower limit, replace x by 1. So 1 minus e raised to 1. That's the lower limit. You may leave here, but we can simplify. As you can see, what is e raised to ln 5? You can enter in your calculator, by the way. It's just a 5, because e and natural logs, when they are adjacent to each other, their actions cancel because they are inverse functions to each other. So this is 5. So the final answer is ln 5 minus 5. Now this negative should be distributed, -1, negative, positive. E raised to 1 is just e. Just e is a number, okay, about 2.7. And as you can see, you can combine the middle two terms, -5 and 1, that's -6. So the final answer is -5 minus 6 plus e. So I'm gonna turn this off, everything, and you guys need to you need to log in again. I mean, connect to me, because it's lagging by more than like 2 seconds.